Yeah, ladies and gentlemen, warmly welcome here to our today's webinar. Today, I have not a scientific performance here. I want to give you practical information about how to use RTD temperature probes. At first here I have a few examples for you about RTD temperature probes, how they are used in process technology. Here, for instance, we have a head, RTD temperature probe with a head. Then here we have RTD temperature probe with a connector, for instance. Here we have a phase probe, for instance, to measure the phase temperature of a tube, for instance. Here we have this the sheath thermometer, which we have in this world of RTD temperature probes as well. A cable probe, and here we have a plastic probe, which you can use in an area where you have extreme high voltage in a motor or something like this. So that are RTD temperature probes, and I want to give you here maybe a little better idea how to work with it. So what is the content of this webinar? At first, I have a little information for you about the platinum measuring resistor, which we use in our RTD temperature probes. So I think you know many times there are used PT100, but as well PT1000, but mostly not so often. Then I want to give you a little information about the linearization. So how is the evaluation of the signal of a RTD temperature probe in such a transmitter, for instance. Then I have information for you about short circuit and line break detection. This works very well with RTD temperature probes. And then I want to spend a little time on the connection types. Maybe you know that we can connect the probes in 2-wire, 3-wire, 4-wire. I want to show you the differences and the drawbacks sometimes, or what is better if you use the one or the other technology. So then I want to show you that it's not so hard if you have a RTD temperature probe with a terminal point in 2-wire technology. Normally when you work with 2-wire technology you have an offset, but if you have a terminal point and if you need to work with your own connection cable, then it's not such a big offset which you have there. On the other hand, if you have a RTD temperature probe with a connection cable and 2-wire technology, this is not so nice because here the offset will be normally more high if you work with a PD100. Then I show you that you have an information about the connection on the thermometers. On the most thermometers which we have, you can see the connection diagram on the thermometer itself. And finally, I want to show you how to detect the connection of a RTD temperature probe by measuring the resistances. So let's start. At first, little information about the platinum measuring resistor. The platinum sensors, PD100, PD1000, they are standardized, and the standard here. There are a few things standardized there, but I want to say the most important thing is that the characteristic curve is defined. So this means if you have a PD100 from the one supplier, you can buy it from the other supplier. You buy always as well a PD100, and from the signal, let's say, it has the same behavior. Okay, this is very good. So if you buy a new device, you have no problems by the replacement. Sometimes if you work with NTCs, it's not so easy because each manufacturer has its own characteristic. Very important point. Then let's look a few words about the linearization. So you have a PD100, a PD1000. How can you get from this RTD temperature probe the temperature? So if we speak about JUMO devices, for instance, the most of our devices, they offer universal analog inputs. So then you can give current signals there, you can give voltages there, thermocouples, and RTD temperature probes. And if you give to such a device a RTD temperature probe like this, like a PD100, then you look to the corresponding analog input. You say sensor type RTD temperature probe, and then the device gives here a defined current to this loop, and we measure here the voltage. According to Ohm's law, the device calculates the ohmic value, and then you say here, okay, linearization. If it's a PD100, you define PD100, then the device works with a characteristic and forms automatically from the measured ohmic value the temperature. Okay, if you have a PD1000, you say PD1000, but it's not necessary to know what ohmic value do you have at 50 centigrade, something like this. It goes automatically. So what is about a short circuit and a line break detection? So imagine you have a RTD temperature probe, and in this RTD temperature probe or in the cable, you have a short circuit or you have a broken line. So here one point is important. If you work with RTDs, both cases, they can be detected by the evaluation unit. Let's say if you have a short circuit, here, yeah, maybe then you have 1 ohm or a few ohms, something like this. It depends on the length of the cable. But the device measures then the ohmic value. The ohmic value is less than what you can expect with a PD100, PD1000, and the evaluation can detect this error. The device can see, oh, there's an error. And if it's a controller, for instance, then the controller can switch off its output. It goes to the safe status. If we would have a line break, let's say we have a broken connection wire, something like this, then we have an infine resistor or resistance, and then the device knows, okay, this is no valid value for PD100, PD1000. The device can recognize that it's not a valid value, and then we switch off the controller output as well. So we can recognize these both situations, and now you can say, oh, this is very normal and we can expect this. If you work, for example, with a thermocouple, we will tomorrow speak about this. In this case, you can't detect these both cases. You can't detect this fault. But with a PD100, PD1000, no problem. Now, I want to give you an information about the different connection types. How can you connect a RTD temperature probe to a field device? In general, we have 3 possibilities. We can give it there in 2 wires, in 3 wires, and 4 wires. In a few minutes, you will see with 2 wires, in many cases, you have there a drawback. This is here standard. And if you have, if you want to reach the best accuracy, then you work in 4 wires. So let's look to the different connection types. So 2-wire connection, that is the easiest way. Let's say we have here PD100. We give it to our field device, and the field device measures and calculate the resistance. But here you can see the resistance, which will be found out, I want to say, is not only the resistance of the PD100. No, we measure always a bigger resistance because of this core resistances here. And if you have a PD100, for instance, and if you have here only 0.4 ohms, which is not much, then your display will be show 1 Kelvin higher temperature. So we have a temperature offset for this PD100 with 1 Kelvin. If it's a PD1000, then with the PD1000 we have with each Kelvin 4 ohm higher resistance. On the other hand, this means if the line resistance is 0.4 ohms, then the offset is only 0.1 Kelvin. This is not so hard. It's not so hard. No, but I think you can imagine very fastly you can have here a few ohms, and then you have a few Kelvin higher temperature display. So how can you manage this? How can you how can you have the right temperature? You need to make an offset. No? You need to say, okay, the offset which comes by the line resistance, I need to compensate. And if you work with our devices, then you have, in the most cases, you have here the possibility defining directly the line resistance. Maybe it's possible because you have here a terminal, something like this. Maybe you can measure the ohmic resistance. Maybe it's 0.7 ohms. Then you give it directly there. Yeah, and then you made the offset. You made this offset which comes, this offset correction, which comes from the cable. Yeah, and if you look here carefully, here you compensate the offset which comes by the core resistance, I want to say. But here you can work a second time and can define an offset. Now, how can we consider this? Let's say we say, okay, define here the ohmic value, and then theoretically you have no offset which comes from the wires in general, and then maybe you make a calibration and then you found out, maybe the temperature probe has a little offset, or maybe the position is not perfect and you need to give one more offset, and this is the offset which we define here. No, we distinguish two offsets, we can say. This is here we compensate the offset coming from the cable resistance, and this is the offset which comes from an inaccuracy of other conditions. Okay, but the two-wire connection, if you have a long cable and a PD100, for instance, you have a big offset and you need to make this offset correction. Yeah, this makes efforts. And on the other hand, okay, sometimes the people don't do it in the plant, and maybe finally we have trouble because of this. If you work with a three-wire connection, then it's much better. Now, if you look to the three-wire connection, then you see here, okay, you give your PD100 to your evaluation unit. Then we give the current through this loop, and we measure here the voltage. But now you see here there's a third wire, and now the field device measures this total voltage which drops on the cable and on the PD100. On the other hand, we measure this voltage, and this is the voltage which the voltage drop on one wire, on one core. And then the device works in this way. The device says, okay, let's take this whole voltage and let's reduce this voltage by 2 times the voltage which dropped on one core, on one cable, on one wire, I want to say. And then theoretically, the transmitter finds out the resistance which we have on the PD100. And this works perfect if here the both resistances are the same. If I have here the same resistance like here, then it works perfect. And normally this is the case because we have different wires in one cable. Normally all the wires have the same resistance. Okay, absolutely accepted in process technology, working with this three-wire technology. So if you want to have the best accuracy, then you can work with a four-wire connection. Four-wire connection, you see it here. Then we say, let's give the current here through this loop, and let's work with these two wires. And with help of these two wires, we measure the voltage drop on the PD100. So we have no influence by the cable resistance, I want to say. This is the best what we can do. And especially it helps if your system is asymmetrically. This means maybe you have here a little other resistance like here, because the terminal resistances are a little bit different. No? Then, okay, if you have such a situation, it doesn't matter for the 4-wire connection, you will compensate this. No? And if you have it not symmetrical, then you would have a little error if you work with a 3-wire connection. 4-wire connection is not very often used in process technology. This is used if you work with a reference instrument, if we say we want to have it as good as possible, or in labs sometimes they work in 4-wire technology, not so often in process technology. Okay, let's look to RTD temperature probes. In 2-wire technology, we said, oh, this is a little bit problematic because of the offset. But if they have a terminal point, then it's not such a big problem. I'll show you. So I'm talking about these sensors here. No, we see here, okay, these sensors here as a customer, I need to give my own cable to the sensors. So they have a terminal point here in this head, or I make my terminal point here in this connector. And let's look what is the situation if we have these probes in 2-wire technology. I told you in 2-wire technology, you have always this offset. But if you have these probes, you can manage this problem normally. So here you see such a probe. You see it here, and you see the 2 wires. If you would give the 2 wires over 30 meters to your evaluation unit, maybe you would have an offset of 5 Kelvin, whatever, no? If you work with a PD100, for instance. So please don't do this. Make it as following. Let's say, okay, here I have my terminal point. And then please use 3 wires here. Normally, then it's absolutely okay. Then you have, for this 30 meters I said, no offset. No, you have only this little offset here because of the 2 wires in your probe. But here normally it's very short. Yeah, maybe you have only a few millikelvin or 0.1 Kelvin, something like this. So offset will be very small. Yeah, and to make it clear, I said here, okay, offset minus 0.27 centigrades. Maybe I found out because of a reference measurement, whatever, that the offset is because of this line here, this 0.27 centigrades. And here I make my offset correction. Now I hope you understand. And to make this 100% clear for you, here I have from this probe, I have a photo of this connection here. So you see here I work with 3 wires. The probe is in 2-wire technology. I give 2 wires to one terminal here, and I give this other wire to the other terminal. No? And this solves in general your problem. And if you want to make it as good as possible, use 4 wires. No? Okay, if you have a temperature probe with a connection cable in 2-wire technology, this is not so good. No? Let's look if you have something like this. If you have something like this, there will be always not such a small offset. Let's look if you work here with a copper cable with different cross sections. Now here I have a small cross section, and then you see the ohmic value per each meter. You see it here. Okay, if the cross section is small, the ohmic value per meter is much. If the cross section is bigger, then the resistance per meter goes down. But here I did something for you. I said, okay, let's look. We work with a copper cable of the sections. Let's look to the offset. If you work with a PD100 and you work with this cable here, then you have for each meter an offset of 0.66 Kelvin. 10 meters means 6.6 Kelvin. This is a lot. If you work with a PD1000, it's not so problematic. With 10-meter cable, you have 0.66 Kelvin. Maybe for many cases it's okay without making this correction if the inquiries, if you don't need it so exact. No? So, but you see here, we have a big offset and we need to make a correction. Here I said, for instance, line resistance 3.7 ohms. And here it's not so nice because the probe is assembled. We have a fixed cable. How to find out the line resistance? No, you can look to the cable specification. If you know it, then you can find this value. But sometimes you don't have it. And then you need to make a correction measurement. You need to work with your temperature, with a reference device as well. This is complicated. I don't recommend working with such a cable probe with 2 wires. Please buy these probes always in 3 or 4 wire technology. Then, how can you find the right connection of your thermometer? Maybe you have 4 pins. What is the one side? What is the other side? In many cases, you find with our probes an information on the probe for the connection. I hope you can see this. It's not so clearly here, but I made a photo of this, of the inside of this head here. And then you see, I have here 1, 2, 3, 4, 5, 6 pins. And then you see here, okay, it's a double RTD temperature probe. And then, okay, this is a cable entry here. And then you see how to connect the one RTD and how to connect the other RTD. No? Many times you have this information on our probes. And then finally, I have a little practical thing here. Maybe you find somewhere a probe with many wires, or you have a lot of connectors in your head. You have no idea what is this. Is this a 3 wire, 2 times 3 wire, 4 times 2 wire, something like this? How to find it out? How to find it out? If you have an ohmic meter, then you can make this as follows. Now you can expect always a RTD temperature probe in 4-wire technology at first. And then let's look. If you measure between the 2 wires here, which are on the same side, you would measure only a very little value, maybe 2, 3 ohms, something like this. Here I said if you measure something below than 50 ohms, then you know, okay, this is a one side of this RTD temperature probe. So the corresponding wires, they have here always a value below than 50 ohms. It doesn't matter if you have a PD100 or PD1000. If you measure here between the corresponding wires, I want to say, then you can expect always values higher than 50 ohms. It doesn't matter if you have a PD100 or PD1000. And maybe you have a double element. Maybe you have one more element with 4 wires, for instance. And here, if you measure between, you have a very high value, you have an infine value. No? And then it's clear if it's infine, if it's so high, then it's clear it must be from other thermometer. Okay, this was my information. I hope you liked it and it was useful for you. Thank you for your attention.